Hello friends. So in today's question, in the arrangement shown in the figure, M1 is 1 kg and M2 is 2 kg. Pulleys are massless and strings are light. For what value of capital M, the mass M1 moves with a constant velocity. So we have three masses M1, M2 and mass capital M. So it consists of two independent strings. Let us call this independent string as A and B, and we have pulleys 1 and 2. Now it is given that mass M1 moves with a constant velocity. Okay, we can say that mass M1 moves with a constant velocity. Okay, and let us say that the tension in the string B, okay, let me write here, tension in string B is T1 and tension in string A is T2. Tension in string A is T2. So if mass M1 moves with a constant velocity, this is only possible under the condition T1 is equal to M1G. Okay, so this will be our M1G and this will be our M2G. So from here we can find out the value of T1. So it means T1 will be equal to 1 and value of G we are going to take as 10. So you can see 1 into 10. So tension will be coming as T1 will be coming as 10 Newton. Now we can find out the relationship between T2 and T1, that is tension in string A and tension in string B. Okay, the relation between tensions of string A and string B is, you can say, T2 will be equal to twice T1, and we simply substitute value of T1 as 10. From here we can get T2 will be equal to 20 Newton. Next we assume that let mass capital M is having an acceleration of A. So based on this we can say that this implies that T2 will include mass into acceleration. From here we can find that A is 20 divided by mass M. Now if A is the acceleration of mass capital M, then the pulley 2 will also be having an acceleration of A. Okay. Thus pulley 2 will also have an acceleration of A, because it is moving in they are connected by a single string, that is A. Now it is given that the mass m1 moves with a constant velocity. Okay, mass m1 moves with a constant velocity. From here we can say that the absolute acceleration of mass m1 is 0. From here we can say that absolute acceleration of m1 is equal to 0. Now based on this we can find out the relative acceleration of m1. Okay. So this implies that acceleration of m1 relative to pulley will be equal to A. Relative to pulley 2 rather, pulley 2 is A and it will be in upward direction. In upward direction. Similarly, we can find out the acceleration of m2 relative to pulley 2. We can say that acceleration of m2 relative to pulley 2 is also A, and it will be in the downward direction. Downward direction. Next, let us draw the free body diagram of mass m2. Okay, so the free body diagram of mass m2, let us draw it. This is mass m2. So in the downward direction it is going to have m2g, and we already found out that it is will be having acceleration A in the downward direction. There will be a force of tension T in the upward direction, and there will be one more force which we can call a pseudo force. Okay, pseudo force, and its value will be equal to m2 multiplied by A, m2A. So based on this free body diagram, so from free body diagram of mass m2, we write all the values. Okay, we can see that this will be equal to 20 Newton, and M2A we already found out is given as 40 divided by M, and value of tension is also we found out is equal to 10 Newton. Okay, this is equal to 10 Newton. If you substitute all these values, get 20 minus 40M minus 10 will be equal to mass into acceleration, that is equal to 2A. Okay, and we already know value of, we already know the value of A, which we found out as 20M. Okay, so we put the value, this will be 20M. Okay, from here we can say that as A is equal to 20M. So if we solve this equation, this will be 10 minus 40M, 40 by M will be equal to 40 by M, and we can say that 10 is equal to, we can take 40 as common, so this will be 1 upon M plus 1 upon M. 10 will be equal to 10 by 40, and this we get as 2M. From here we can find out that value of M will be equal to 8 kg. So this completes the question. Thank you.